Right? Make sure your name's at the top with a -1 after it. And let's hand those up and over. Now, have those out, please, and have your homeworks out. We'll have you hand the homeworks up in just a second. From your assessment today, I start off with the first question. What do I have to do to get an answer on that? 2 people. 3. Because what's that going to result in me removing? Where? In the denominator, yeah. So when I do this, there's 2 parts of this that are going to be, that we have to do. The first part, when you go through, is you would distribute out in the numerator. Nobody should get that wrong. You get 2 plus root 11 over. And now we need to figure out what's going to be in the denominator, so I go over to the margin. I list out the binomial twice. Now I've got to FOIL this. First out and last, first terms multiplied together are going to give you what?
-6.
No. First terms give you what?
Oh, first terms
4. And then we get a positive 2 root 11 and a -1, and then at the end you get an 11. 4 minus 11 is going to give you a -7. So then you sit there and go, now, instead of panicking, going, oh my God, that's not one of the answers. It doesn't look exactly like it. Well, which one is the same as the answer you gave? Yeah, choice C.
So I thought you meant what you would get when you square those 2, not just the 2.
Now, for our next one, we're going to do the exact same thing. What ugly one do I need to use in number 2? Hands up, please, when you can tell me. These are the things that are concerning. Seriously? Seriously? What ugly one would we be using to get an answer out here? Chloe, what do you say? 3 plus radical 2 over 3 plus radical 2. I distribute out. The numerator is so easy. Now the denominator I need to FOIL out, so I get this. First terms multiplied together are going to give me 9. Outside and inside are going to reduce, and at the end I get a -2, so that leaves me with a 7. So I go through now. You're probably going, well, that's not an answer choice. And you're right, it's not. We're asking you to take the drastic step of recognizing that both of those numerators and denominators share something. What do we do to go forward from here? Allison, Al, what do you say? You have to divide them all by 7. And if you do that, 21 over 7 is going to give you 3. 7 over 7 is 1. So your answer choice should be A. Questions on that one? Which one out of these remaining ones was the toughest, do you think?
5.
5? All right. Taking a look at 5. What perfect square goes into 54? Maddie? What perfect square number goes into 54? You know? Tyler? 9. 9 times what? Okay? So I break this down, and there's a 6 in front. What about 24? Jess, what's the biggest perfect square that goes into 24? 4 times what? What about 96? Alyssa, what perfect square goes into 96? Use your calculator if you need it. We have to be able to come up with these values, kids. 16 times what? So now you can go through from here. Square root of 9 is going to be 3. Square root of 4 is 2. Square root of 16 is going to be 4. These get multiplied together, so I have 18. Over here, when I take the square root, I'm going to have a 6. Over here, I'm going to have a 32. Are those all like radicals? Absolutely. So now when I go across, I just go through and we've got 18 minus 6. 18 minus 6 is going to give you 12. Then you've got minus 32 more. That would give you a now, the part we have to get is you have to know your division factor. If you need the calculator, use it. I could care less. But we have to know our perfect squares, our perfect cube numbers, and you don't need to memorize them. The calculator is there to help you out. By the way, you can tell me what perfect cube goes into 24. 8. 8. You can tell me, please, what perfect cube goes into 375. 125. So from here, we would go through, and the cube root of 8 is going to give you how much? 2. So take that and multiply by the 2 that's in front here, and you get a 4. Over here, the cube root of 125 is 5. Multiply that by the one that's in front, and you get 25. From here, the next thing that we would do is subtract, and you got negative 21 root 3. Okay? You have to be able to take those steps. You've got to know those perfect cubes. Questions on this? Okay. Have your homeworks out? These are the answers to them. Did I fit it all in one? There we go. Those are the answers to those questions. Go back and compare to what you had. If you've got questions, we've got a couple minutes where we could answer them. Tyler?
It's 35. I just wrote that in the original question.
Sure. Sure.
This is kind of off topic, but is there a way to like simplify radicals with different indexes?
Yes, but you can't combine them. Like, you can always take a cube root or a square root of any number, but there's not a way to rectify that yet. Meaning to make it so that they're sort of talking the same language. It's like having some money, some American money and some Canadian money. Okay. Which ones out of this group would you like to see? Yeah. The last 3. All right, so we'll bounce over, and that was, which one, if we had to pick down one out of the last 3? Any of them? All right, let's try 34. Okay, so if I'm doing this, rationalize it. Now, the first thing that I would go through and do is, when I see this, I'm going to put it under one big radical to start. Because something good is going to happen now, 5x to the 4th, y all over 2x squared, y cubed, right? Who can tell me what this expression would simplify into? We said yesterday you need to be fluent in putting them in, putting them out. Look at what's here. All of a sudden some stuff can reduce out. What's a reduction that I can do when I'm looking at this? Michael, what do you say?
The x to the 4th divided by x squared is equal to x squared.
Where is that x squared going to be, in the numerator or the denominator?
Numerator.
Okay? What's another reduction that you can go through and do? Johannes, what do you say? Okay? What are you left with and where when you reduce those? Okay? Now, is there any more reductions that I can do? Is there? Is there any more reductions that we can do now? Technically, there's parts of this that I can handle right away, though. Does anybody see what we can do to proceed forward? You're looking at this right now. Johannes, what do you want to do? What's the square root of x squared over y squared going to give you? So those are now gone. And I could, at this point, split up. You've got the square root of 5 over the square root of 2. This still isn't all the way gone. What's the one thing we need to get rid of that's there? The radical that's in the denominator. Hands up, please, if you can tell me how I can get rid of the radical 2 that's there. There's a radical 2 in the denominator. What can we do to get rid of it? The x, you can leave, or sorry, the y, that's fine in the denominator. What can we do to get rid of the x, or sorry, the root 2 that's in the denominator? We got 2 people who can tell me, seriously? 3? It's fine. There's no firing squad if you get it wrong.
You multiply by radical 2 on the top and bottom.
Yeah, numerator and denominator. What is the, are you changing anything by multiplying by a root 2 over root 2? Because what's that the same as? It's the same as this is an ugly 1. But what's the benefit of what you just said? You mumbled it. What?
You can get the radical on the bottom.
Yeah, out of the denominator. So when you multiply all three of these, what would you be left with up top? All you have to do is multiply.
Well,
What's,
would the x go under the radical?
is it under a radical now? So you can't just put it under one. So what do you have?
X, yeah.
And what about down in the denominator? What's y times root 2 going to give you? Right? Questions on that one? You can always separate a radical into its fraction components if there's a fraction in the radicand, and vice versa. Sometimes you want to. Now, technically, if you're doing this, I could have said, well, what's the smallest thing I can multiply by such that this, you could have also multiplied this to start with, saying, 5, x to the fourth, y, all over root 2x squared, y cubed. What do I need to multiply this by? You could do it all at once. You could multiply by, what did you say? Root 2y, right? And now what are you left with down in the denominator? And what's in the numerator? Can you simplify the denominator? Sure. That goes to 2xy squared here. And then in the numerator, you would have root 10 stays the same. This would be x squared and then a y. But then this has a reduction in it because what reduces out here? An x from the numerator and denominator. That leaves me with 1x. These leaves me with y down below. So x root 10 over 2y. There's more than one way to do it. You just have to be able to justify what you're doing. All right, do this please. Make sure your name is at the top with a dash 1 after. Let's hand those up and over, please. And have your note packets out, open to where we left off, which is topic 2-3. What page is that on? 11, all right. Have your notes out and open to page 11. Now, as we go forward, this is actually one of the topics that I think that we do that's a little bit easy. But the problem is that, again, some of us have this either inability or inflated sense of algebra confidence. You have to understand there's add, subtract, multiply, and divide. We've got combining like terms. You need to know how to expand things or multiply them by themselves. So if I give you something and I square it, that means you take it and times itself, etc. If you can get that part down, these are very much like a rote, repeatable type of situation. The other thing is we're going to show you how to use your calculators to check your answers, so sign in if you haven't already. If the index is even, the square root is the principal or positive answer. We talked about that before. If we go through and you've got a square root, it's only equal to the positive of a number. Now watch what happens when we go through and put that in action. Was that one of the ones you had to write down, or was that given to you?
Yes.
It's given to you? All right. Take a look at the first question. It wasn't? Sorry. So get that down then if it's not. I'm sorry. If n is even, if the index is even, then the square root of x is the principal value. That means it's the positive one. So what we're talking about is, if I give you the square root of 25? The answer is 5. It's not plus or minus. If you have x squared equals 25, then x is equal to plus or minus 5. That's the difference. Remember we told you, if it's squared, you have two potential answers. But the principal root is only the positive one if your index is even. You don't do plus or minus. Do we have this down? All right. Take a look at our first question. We need to solve this out for x. The first thing that you're going to want to do is isolate your radical. So, Jensen, what would you do to isolate your radical? Subtract what? And what am I now left with? Is equal to? So I've isolated my radical. That's your first step. If you're looking for that procedure column, you can write that down. Your first step is always do everything you can to isolate your radical. Now, once you've isolated the radical, Alexa, what do you do to get rid of the radical? No, radical is a square root. What's the opposite of square root? Square both sides. There you go. So now, when I square both sides, what would I be left with on the left-hand side? Emma K? And what would you have on the right-hand side? So from here now, the next thing that I would do is, I need to solve for x. From what I understand, this is all you did in geometry. You go through, you subtract the 1, so we've got 2x is equal to 8. Divide by 2, x is going to be equal to 4. Now, you have to go through and check every answer with the square root equation, because it's possible when you square something to get what we'll call an extraneous answer, which is like a false positive answer, or an answer that the question generates that isn't valid. Because when you square something, you introduce sometimes a second answer. So what we're going to have you do is this. Go over, please, to your calculators. Make sure you're in a document. Go in and do this. Go to a document. You're going to go to Add Calculator. And now you're going to do this. Type in what the original question is. So put in the square root of 2x plus 1 in the radicand. Get out of that. Plus 2 equals whatever. Now, the next thing that you're going to do is this. Don't hit enter. Hit control equals. See that bar? Try the bar. Select it. And then after the bar, you're going to put in x equals, and what answer did we get? 3 or 4? 4. Do x equals 4. Does that work? Is that an answer? Press enter. It says true. That's how you can check. Every answer you get with the square root equation, though, you have to check. Because sometimes we'll be getting, or we'll lose negatives that need to be there because we're squaring terms, etc. Questions on that? And another thing, by the way, as long as we're on this, we'll deal with this now. Have you had people before that told you guess and check was a viable way to solve?
Yeah.
When? Okay.
Seventh grade.
When was
Yeah, what?
last year?
Yeah.
Let me make it unequivocally clear. Guess and check is not math, does not earn any form of credit in the least. I don't know why they would tell you that. It's a complete and utter fallacy. Guess and check does not work. It at best is a parlor trick to get partial credit on a Regents exam. That's it, at best. On a test, that gets you absolutely nothing, even if it's the right answer. Absolutely, positively nothing. That's why, because some people will sit there and literally start plugging numbers in. Once they notice, they go, oh, it's 7, it's 8. That gets you nothing. You might as well draw a picture of a dinosaur. Okay. Now, the other end of it is this. On a Regents exam, Could you go through and do that on every possible multiple choice question? Sure. But that's not math. So when you get a free response question or you're answering a question here, it's not going to earn you points. Let's take a look at the next one. Is it the same one twice?
Yeah.
Oh, okay. Let's bounce over now. Please take a look at question number 2. If you do out question number 2, understand this. When we're doing this, we may be getting quadratic equations, so part of this may be a review from what you've done before. This is why we did the unit we talked about in the beginning. That's why we did it now. Take a look at question number 2. Our first step is going to be to do what? Colleen B, what do you say? Subtract 1, because what are we trying to do? Terrific. So now I've got x minus 1 is equal to the square root of x plus 11. What would we go through and do next? Vicki?
Square it.
Now, you have a binomial squared. So over in the margin of your paper, you are going to list out and tell me what you get when you take the quantity x minus 1 times the quantity x minus 1. By now, you should be able to do that in your head. But go through and do that. Hands up, please, when you can tell me what you get when you take the quantity x minus 1 and square it. We'll wait for 9 of you. We've got 3, 4, 5, 6, 7. We're getting there. This should be very, very, very quick, hopefully by now. We're at about 8. What do you want to say? Terrific. X squared minus 2x plus 1. A unifying theme of this course is to recognize this is a quadratic equation. You can tell by looking at the degree or highest exponent. If there's an x squared in it, how many answers am I going to get by solving this equation? 2. We're going to need to bring everything over to one side, and then hopefully all of these will factor down. When I bring everything over, I'm going to subtract an x and an 11. So this is going to leave me with x squared minus 3x minus 10 is equal to 0. From here, your next step is to recognize this factors down. That's why we did all of that work in the beginning on factoring. They should have been doing this with you the entire time. Hands up, please, when you can tell me what 2 binomials this will factor down into. We've got 1, 2, 3, 4, 5 of you. We need numbers that add to -3 and multiply to -10. I'd start with the factors of -10, work my way to -3. Tell me the 2 binomials, please, that we get. We've got seriously 1, 2, 3, 4, 5, 6, 7 of you. What do you want to say, please? X minus 5 is 1, and what's the other one? Terrific. Now, this is the part where I don't know if you did it before, but it's not that difficult. Does anybody know what we would do from here?
I don't know. I did
Oh.
this in my 8th grade, but like, is it x equals positive 5 or x equals -2?
You're missing one step in there that you have to show that's not optional. This is called the zero product property. What that means is anything times 0 is going to give you 0. So set the left and right half of the product equal to 0. This is not an optional step. The solving you can be a mental math all-star at. Now, I have 2 candidates for answers. How can I check to see the answers that work? What I need you to do is go back to the original. You're going to type that into your calculator. Again, we have 2 candidates. Plug the original, please, back into your answer. And now you're going to put that bar there. Does 5 work? Absolutely. Now, and here's a shortcut. I don't know if you know this. You don't need to retype everything. If you arrow up twice and this is highlighted in blue, hit enter on it. And then change the 5. What was our second answer? -2? All right, -2. Press enter. You get false. So one of the answers is what's called an extraneous solution. At least one. Some people will start thinking, well, we always get rid of the negative. Wrong. Absolutely wrong. you get rid of the answer that doesn't work in the question. So now I'm going to go back over here. Underneath this, I write reject. And before I circle my final answers, I've gone through and checked them to see if they in fact work. Now I go back and look up here. Can anybody tell me, just by looking at the question, why you know the answer can't be -2? Think about what we talked about with range, which is the alphabet. Why can't the answer be -2?
Yeah, it's square root of a negative number.
Not necessarily, because if I put like, well, you're right, but you can, see how there's an expression there?
Oh, so it has to be more than.
Your output's over here. Think about what's going to happen. When you plug a -2 in, you're going to get some sort of output. Notice, -2 plus 11 leaves you with, how much? 9. You can take the square root of that. So it doesn't fall apart. -2 is in the domain of that radical. What I need you to see is, where's the problem going to be? I can't have a negative answer because, see how it's equal to -2? Is the square root ever going to give me a negative output value? No, it can't. The square root's always going to give you a positive output. So the positive number plus 1 can't equal -2. But again, check them algebraically. Use a calculator every time. Now, this next one is going to be a little bit more difficult. We're presupposing that you can do the easy ones like the last two. This one's going to be more challenging. Looking at what's there, how many radicals do I have? 2. What I need you to do is this. We're going to call it balancing out the equation. This is going to require us to square twice. This one, the algebra gets a little bit messy. I don't believe the Regents is going to ask you to go this far, but we need you to be able to for pre-calc next year, so we'll get it started now. First thing I'm going to do is pick the radical that's the more complicated one and get that alone. So looking at what I have now, this radical here is the more complicated of the two. So what I'm going to try to do is get that alone. I'm going to go through and subtract root x from both sides. So I've got the square root of the quantity x plus 5 is equal to 5 minus radical x. Any questions on that? Who can tell me what you think you want to do next? You all are problem solvers. What is our next step in this process? Terrific. Now, one side is going to get really easy and one side is going to get really awkward. Which side is the one that's going to get really awkward? The right side. But again, it's not math you can't do. We're going to square both sides. So we, as of now, have an x plus 5 on the left is equal to, now over here you've got to recognize that this is 5 minus root x times 5 minus root x. That means I need to FOIL it. Go through and FOIL that out right now. Hands up, please, when you can tell me what that expansion is going to leave you with. That's terrific. 25 minus 10 radical x plus x. Oh, wait, sorry. You said minus, right? Oh, it's plus. You're right. I'm sorry. I thought it was a constant. Same term twice. Now, watch what happens at this point. Let's fill that back in over here. So I've got 25 minus 10 root x plus x. This is actually kind of easy. What would we do from here? Hit the radical alone again. How are you going to make that happen? Who can tell me what we would do to get our radical alone? What are you going to subtract? So let's subtract 25 and subtract an x. So let's do minus x, minus 25. Look at how clean all of a sudden everything gets. These are gone. This is now gone. You're left with negative 20 is equal to negative 10 radical x. Who can tell me what the next thing that we would do is? There's actually two viable paths to this answer once you get to here. You can divide both sides by -10. So you're left with 2 is equal to the square root of x. I'd square both sides and be left with 4 equals x. Before I circle it, what do I need to do? I need to check to see if it works. So go into the calculator and see, is that in fact a valid answer or not? What's our verdict? That's true. It looked like it was going to be really awkward, but the funny thing is, if you go through and do it, which step was the most complicated math that we did? This one here. Because we had to square that binomial. But that's pretty much it. You get a radical twice. You have to square twice if there's 2 radicals and you balance it out. Now, let's go over, let's take a look at question number 5.
Are we skipping 4 on 2
I want to make sure we finish. Take a look at it, question number 5. Hands up, please, if you can tell me what you think your first step's going to be in number 5. You got 1, 2. Be a problem solver. What do you think that this is going to be? Eli, what do you say? Let's subtract an x from both sides. So now I have the cube root of x squared plus 2x is going to be equal to 2x. Hands up, please, if you can tell me what I would do next. Make sure you're paying careful attention to how that question is given. What would we do from here? Terrific. It's not a square root, it's a cube root, so to get rid of it, you're going to have to cube both sides. This is where some of us are going to fall asleep at the wheel here. The left side's going to be x squared plus 2x. Hands up, please, when you can tell me what the right side's going to give you.
And also, it's a square root and
Hang on. 8x cubed. Oh. There you go. Now, what would I do from here? What's our next step to do from here? Set it equal to 0. Now, this would be the term of highest degree. So what I need to do is bring all of this over here. I want that to be positive. So I'm going to subtract x squared and subtract 2x minus x squared minus 2x. From here now, I'm left with all of this is gone. I've got 0 equals 8x squared minus, 8x cubed minus x squared minus 2x. How many answers am I supposed to get from this? 3. Now, that leads me to believe that this needs to be factored. What's the first step in factoring this down? Take a look at what's there. What's your first step in factoring this down going to be? Take out your GCF of x. And that's going to leave me with a 0 and equals, and I've got 8x squared now minus x minus 2. Looking at what's there, you've got to ask yourself, is there a way that I can factor this down? And it's going to be awkward, of course, because as it is right now, I've got numbers that need to multiply. Well, you try to factor that down. Your lead coefficients could be 2 and 4 or 8 and 1. Try to factor that down by guess and check. Did we go over the shortcut to check to see if something factors out the long way or no? Okay. Here's a way to check to see if something factors out. Take the product of the outside numbers. What do I get if I multiply my outside values? Negative 16. Are there numbers that multiply to negative 16 that allow me to get out a negative 1? numbers that multiply to negative 16 and add to negative 1. Are there? No. So, what do we need to do to solve this out? Well, we'll do what we said before. We'll apply our zero product property. I would get x is equal to 0 from setting that equal to 0. That gives you your first answer. Here's the part where we're stuck. 8x squared minus x minus 2 equals 0. That does not factor down. But there's still answers to it. You all should have done the quadratic formula. Is that right? Have you heard of the quadratic formula before? If you need a refresher, here it is, listed out. X, if you didn't, you just be quiet and start writing down. B squared minus 4ac all over 2a. That's the quadratic formula. X is equal to negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Remember, in this case, we'll list it out so we're all on the same page. What is my a value for this question? Hands up, please, if you can tell me. One person? Two? What do you think? 8. Hands up, please, if you can tell me the b value for this question. Yeah. Negative 1, and what's your c value? Negative 2. Now, we do this so often. I don't need you, and some of you, they tell you have to write things that you don't. I do this so often, and we do it in Algebra 2 so often, that I actually have this so I don't have to write it out every time. You're going to list out what we call the shell of the quadratic formula, which is this formula with colors here, because you're going to just tell me number values that go there. What's the number value that goes here?
Negative 1.
It's got to be the negative of your b value, so it would be a positive 1. What goes in the blue down below? Hands up, please, if you can tell me. What goes in the blue value down below? Careful. What did you say it was? 16. Yeah, sorry, I thought you said negative 16. Now, the next thing that we need to do is take our b squared minus 4ac. I don't need you to write it out. That's garbage work. I don't even want to see it. Go into your calculators and type in parentheses, the b value. What was the b value? Negative 1. Then get out of that squared minus 4 times, what was our a value? 8. And our c value, which was negative 2. All right, press enter. 65. Do any perfect squares going to 65? Well, give me some candidates. Who can tell me a perfect square number that could go into it? Hands up, please, and tell me any perfect square that is possible could go into it, or that's less than 65. 4, does 4 go in? No. You can give me another one if they want to try. 9, does 9 go in? No. What about 16? No. What about 25? No. 36? 64? How many answers does this leave us with? It's plus or minus, so that's 2. How many total answers were we going to get from this to begin with? 3. Now I'll show you this. Go back up, please, to the original question. Let's type these in and watch what we get. Go back up to the original, and let's type in the original expression. And we're going to do the bar trick to see whether or not these answers work. So x plus the cube root, and if you need the cube root, remember it's control and then the caret. X squared, keep going, plus now do the bar. And how many ones do we have to check? There should be 3. So let's go in, and our first answer would be x is equal to 0. That should be the easiest one. Does 0 work? Yep. All right, now go back up and select that. Now you're going to delete that, do control division. And then in the numerator, again, we got 2 answers from the quad. So one is 1 plus the square root of 65. All over, what was our denominator, 16? Does that work? Okay, now let's go and check our second one. Hit enter. Go back and change that plus to a minus.
No, true.
There you go. So do all of them work? Absolutely. Was that something that you could do? I would say this. You need to know the quadratic formula to solve, and we're going to mix the solving in. My problem is this. We're under the impression that you did solving quadratics, or you were supposed to be doing that instead of those linear equations all year. And since Algebra 1, the courses need to be connected. They shouldn't be sort of separated. Now, looking at this looks so complicated, and it's so easy. This is so easy. Hands up, please, if you can tell me what your first step you want to try to be. That's terrific. So I'm going to square both sides. So when I do that, I'm now left with the outside radicals gone. So 1 plus the square root of 2 plus root x is equal to 9. Who can tell me what my next step is going to be? What'd you say? You are right. Subtract 1 from both sides. So now I've got the square root of 2 plus the square root of x is equal to 8. Hands up, please, if you can tell me what you want to do next. We're going to square both sides from here. Keep going. Now, what do we get now when we square both sides? Hands up, please. You tell me what I'm going to write down next. 2 plus root x is equal to 64. From here, I'm going to subtract 2. I'd be left with root x is equal to 62. Now I'm going to square both sides.
3,844.
3844.
Yeah.
Okay.
300.
Go back and check your answer. Does the answer work?
Nope.
Does it?
No, it doesn't.
Are we sure? Let's see. Get outside of everything. Do the bar. Hang on. Oh, equals 3. Yep, sorry. Then do the bar. I thought this was going worse. Okay. There you go.
Oh, I did something wrong.
Oh, I think a bar.
Now, was that manageable? Absolutely. What I need you all to understand is this, and part of my frustration. Like, I'll say, what personifies it is your quadratics. In all honesty, you all should have been banging those out over and over again. Factoring should be something automatic because we never should have stopped doing it after Algebra 1. And by no means does it mean, that you have some life sense of never being able to do it, because again, we're going to resume where you need to be, and you'll get there. You have to be able to sort of take that say, I'm not afraid. Who here is afraid of a quadratic equation? Who here is scared of one? You can be scared of the boogeyman. You can be scared of the rounding fairy. You cannot be scared of a quadratic equation. Now, I'll say this. Actually, let's do this. As long as you all are here now, go back. Rich. So today was 2-3, was that right? For those of you that would like to, for your homework tonight, you want to go through and take a picture of that. These are the answers to the homework. If you want to use your phone and take a picture of it, that's the answers to your homework. I love it. Work towards those answers. Make sure you check them. And I'll try to take this as a picture and send it to you all tonight. I'll try to find a way. I think if I take a snip of this, it should work. All right? Sorry if I got in your pictures. But, good job today.